This is the basics on a captive air makeup air unit at Applebee's that we work on. I'm going to point out the heat real quick. You have a fireye, which controls the heat. This burner on-off intake air thermostat, depending on what the temperature is outside, will turn on or off. Right now it's set to 54 degrees. Once it reaches 54 degrees or colder, this sends power to this. The optic circuit will turn on. And once the airflow is sensed, that light will turn on. PTFI stands for your pilot. Once the pilot turns on, that'll tell you that it's igniting. Once it senses the pilot, the main burner will kick on, which is your flame. And if it has issues with either of these two, it'll go into an alarm. And to reset the alarm, you can just turn this until the system clicks off and then turn it back. Or you can shut the power off at the switch, turn the power back on. You have a damper on this particular unit. It's inside here. Once the damper reaches its opening, it closes a relay, which sends power to the coil here on this overload contactor. Then the contactor pulls in, which operates your blower. You have a transformer 208 to 120. And then once your blower turns on, again, your airflow will sense and your heat will turn on. Also, when that contactor closes, your air conditioner will run. You have your outdoor air sensor, which obviously see it's outdoors. Your discharge air sensor for the air conditioning, they got this one stuck inside the blower housing. This one's set to 69 degrees. Once it reaches 69 degrees outside air temperature, it'll send power to the relay inside here, and it has a first and second stage, and it'll start the condenser's first and second stage. It's just a regular thermostat. It has a time delay so you don't short cycle the compressors and mess them up. You have an amplifier, ctrl Selectra A1014R. This is what controls the temperature of the heat. Right now it is set to 68 degrees. This is your discharge air sensor for the heat. It's a TS114F. This sensor, it says it's 40 to 80 degrees, so it actually doesn't match the sticker on the amplifier. This one goes from 55 to 90, but that's not too big of a deal. I mean, when you replace these, you can call up Cochrane and tell them you want a ctrl Selectra A1014R and you want the discharge sensor for it to match whatever you want. 55 to 90 is usually where we pick them up at, and that should be a TS114. That should be, don't even quote me on that. But that's these two wires right here is your discharge air sensor. These two wires here, depending on the call, will send 0 to 24 DC volts to your modulating gas valve. Once the flame is recognized, it'll power up these transformers. It'll send power to the ctrl, and then everything else will work accordingly. This here, it has a minimum position opening, so it is always open. And then again, 0 is minimum, and then 24 volts is maximum opening position once it receives that DC voltage. Here's your 24 volts DC, or AC for the pilot. This comes off of your fireye. It's got a pilot tubing. The pilot ignites. The flame sensor senses it. And then the fireye will open up the main valve. This just opens and closes. and then allows the gas to flow through here, and then this just modulates to maintain a temperature. Again, if we had the right discharge air sensor, it would be maintaining about 68 degrees, which, I don't know, if you get close to that within 5 degrees, plus or minus, you're doing real good. You have a dual pressure switch. If you go too low or too high above the differential, it will not send voltage to your airflow switch. If you ever needed to test it, you can put your manometer here and zero it out, and then put it here, and you should get about negative 0.22 to negative 0.4 inches of water column. Again, if you go too far below that or too far above that, your pressure switch probably will not send voltage to the fireye. But if you don't have a digital manometer, which you should have, you can always just go plug your manometer in here, and it says, oh, you got 2 inches of water column. You can pull it off and put it here, and it says, oh, you have 1.5 inches of water column. Well, you know, you have 0.5 inches between the two, and then you have too much of a differential there, and that might be why your pressure switch isn't closing. You have your high limit, essentially is a sensing bulb just above the burner. It's set to 180 degrees. If your blower is not running and your flame's on, it should trip. Cause this to trip. This particular one, this is your spark ignition box. That is about it for these. All right, I'm gonna do a quick run through of the heat. You can see the damper slowly opening. Once that reaches its full position, the relay will pull, the contactor will pull in, and the blower will start up. And then we'll look at the heat. So it's about to turn on. Any second now. Come on, there it goes. Blower is on. I'm gonna set my meter to DC volts. On the fireye, I have my leads hooked up to TP1 and TP2. As you can see, they're just clipped on right here. That will tell me what voltage I'm receiving from the flame sensor. You want 12 to 14 DC volts. That tells you you have a strong flame. It's sensing it really good. That makes the system really happy. I have seen them run at 4 DC volts, but that could either be, the first thing I do is replace a flame sensor, and then I check my lead here on S2. This is the wire that goes to your flame sensor. Sometimes corrosion builds up on them. You need to pull it out, cut it, put it back in. Or your ground wire, which actually goes to the ground here, could be corroded. You want to make sure that's nice and clean. Or inside the unit where it connects to the flame sensor, you want to make sure that is nice and clean as well. So I'm going to turn my air temperature up because it's warmer today. I need to go up to turn my heat on. All right, so we got power, we have airflow, then PTFI. It'll sense the flame, and then the flame will kick on, and then PTI will fade out. And we'll look here. I have 16 volts. Beautiful. It doesn't get any better than that. Again, it's DC volts, so it's sensing the flame quite well. My Maxitrol Selectra little lit light is on, so it's getting power. It is heating. You can watch the little discharge air temperature here on this particular unit, so the heat is rising because it's working. That should be it. Side note, on the side of the fireye, it's kind of hard to see in the video, but you can read what it says. I see blower motor, neutral line, lockout alarm, airflow, interlock, and then some other stuff. Those are all numbered and represent here, so you can always trace the wire and it should go back to exactly what those represent.